Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so why don't we go ahead and get started. It's my pleasure today to introduce Chris Poyle from the University of Waterloo. He'll be getting his PhD very, very soon now. Chris is a little bit different from many of the speakers that we get here in this room. He comes from a School of Management Sciences and has an organizational theory background. But I can promise you, since he was our intern, that he knows how to speak ordinary English and talk to geeks just fine. It won't be all technobabble. In fact, it probably won't be any technobabble from organizational behavior. And he's going to tell us today about his research on coordination among software development teams, a topic that is near and dear to our hearts. So.
Thank you very much for coming. My name's, as Rob said, Christopher Poyle, University of Waterloo, Department of Management Sciences in the Faculty of Engineering. I've titled this talk, The Social Programmer. So I'm starting from this assumption, that it's been a very long time since there was a lone programmer in his own room who could produce commercial quality software. These days, software projects require almost every type of organizational role. And when we split these tasks into separate roles, these roles require coordination and collaboration. It's created a complex problem because all these roles need to communicate in order to get their job done. So this is what this talk is about, coordination in software development and how social and task forces influence it. So in this talk, I'm going to be using a concept called task structure. And I'll be using it throughout the talk, so it's good to just review what I mean by task structure. It means different things for different people, and so let's just clarify what I mean by that. We have two people, A and B, and they both have a task. And for example, one task could feed into another. So task A feeds into task B. That means task B has a dependency on task A. They use or consume what task A produces. Now, of course, it could go the other way. Task B could feed into task A, or it could be reciprocal. That's what we call that. Or task A and task B could share resources. So this is what I mean when I say task structure. It's the interrelationship between people and their tasks as they're getting their work done. So what I'm specifically interested in this talk is when one task feeds a lot more into another task. So when task A feeds a lot of their output into task B is said to have an asymmetric dependency on task A. So even if task B feeds back into task A, it's not to the same extent that task A feeds into task B. So that's called asymmetry. And I'll be focusing this talk on this kind of task relationship, an asymmetric task relationship. So I'm going to just briefly describe what the point of this talk is so that we know where we're going. So this talk will show four things. One, it shows that an asymmetry in dependency will lead to a difference in perceptions among the people involved. Two, it'll show an asymmetry in dependency will lead to a difference in behaviors. And three, it'll show that an asymmetry in dependency will lead to a difference in expectations. Fourth, I'm going to describe how a person, a worker, let's say A, this worker is in what we would call a work situation, and there's a field of forces, both task forces and social forces, that are acting on him that in some part and in large part determine the actions that he takes. So that's the theoretical argument that I'll be making, and that's point 4. So let's start. Now that I'm showing where we're going, let's see how we get there. So we'll start with the story of Jane. Jane's a PM, a program manager here at Microsoft. She has a dev and a test who are her peers, and they form a feature crew. Now, Jane also interacts with a feature crew on the same floor, and she interacts with that PM and that dev. And Jane also interacts with a feature crew in another building, and she interacts with their PM and their dev. Jane also interacts with a feature crew in India. So we have global software development issues. She interacts with their PM and their dev. Now, an interesting thing happened while we were observing this situation, or a little bit before the interviews. This PM in India moved, and they moved to the other building. So now their dev and their test depend very heavily on a PM that is not located with them or even in the same country. Jane also interacts with a team from Boston, but their tests aren't in Boston, they're in the same floor. And Jane interacts with their PM. So this is actually a quite simplified version of what's really going on, and we call this Jane's social network. This is why I think this is why I think software is very interesting. This is the social PM, this is the social dev, this is the social test. We now know through previous research that software projects are heavily influenced by social factors. In fact, it's one of the founding principles of the HIP group. It's about people working together. I'm going to engage in a somewhat dangerous activity here. I'm going to try to graph previous research, and I'm creating a false dichotomy of theoretical and practical. It just serves the purpose for this talk and to situate my work in previous work. We tend to see that a lot of theoretical work bunches up in this area, and that's a lot of management work. And we see a lot of practical work bunches down in this, tends to be in this area, and that tends to be software engineering related. So my work falls a little bit into both camps. The exact position, of course, doesn't matter, and in some cases was because I wanted to clearly show the text. So just the important part is the area. So my work falls into both very practical, as I'll show you the interview methods and observation methods that I've used in the past, and in the theoretical part, as I'll show with a field theory way of looking at the situation. So together, I hope when you combine my type of research, it'll lead to something somewhere in the middle. And I think my goal as a researcher over time is just to kind of fly off to the right. Hopefully not too far. So now that we know where this is situated, we have some questions to ask about Jane's situation. The basic question is, how does Jane get her work done? And we can take a social network approach, and we see that her task networks don't follow organizational lines, and they span organization group boundaries, and these groups may have competing goals and competing personal situations such that their small groups' goals don't really contribute to the overall system. So it's a complex situation. And what we want to know is how to take a look at this. So one thing that's interesting is that this analysis, the social network analysis, misses a few things. First, it doesn't tell us the specifics of the interaction. So we know that A and B communicate with each other, and we know direction and in some cases the weight from some analysis. But we know that communication does not equal effectiveness or effective communication. And that's represented by green lines. So a helpful interaction between task A and task B. Communication does not necessarily mean that. In fact, in some cases, communication indicates that there are unhelpful interactions between task A and task B. For each, also what this doesn't tell us is that for each task, there may be different networks of interactions. So for task 1, Jane may have a certain pattern of interaction with each of their own helpful and unhelpful relations. But her other task may have a completely different interaction pattern with their own helpful and unhelpfulness. Yes?
Could you give me an example of the difference between one? I'm assuming the communication between A and B is just verbal hallway conversation. Maybe one example of that. But then, if that's true, what would be the communication between task A and task B, having tasks communicate?
So the question is there a difference, I guess, between social communication and task communication?
Yeah, I guess I'm trying, maybe I misunderstood the notion what the lines between task A and task B meant versus what the lines between A and B meant.
So what I mean by that is you can have communication between person A and person B, but it's not necessarily task-related communication. So a task-related communication would be the lines between their tasks. Yeah. So the question is, how do we get this data then? How do we get this rather complicated, messy information? And one way to get that is through social observation and interview methods. So I'll give you some example interview questions. I've described this in a paper that I just recently submitted. So we first asked Jane, who do you interact with in this task? And so she says, I interact with these PMs and these devs. And I also interact with Boston in India. I also interact with an external group. And she interacts with a technical system product studio. So in this way, we have social technical interaction, because as a lot of devs will tell us in Microsoft, product studio significantly affects their task and their ability to get their work done. The question that we ask is very specific. When you interact with this person, can you give specific examples of things they do that help you get your job done? And then we ask the other specific examples of things that don't help you to complete your job. So the interview method is actually quite simple, but extremely powerful, because it gives us data that are examples of actual behaviors. And those behaviors are significant and meaningful to the participants. The examples are context dependent, situated, and ecologically valid, and they avoid ungrounded opinion and stereotype. So what we really want to get away from is language. Language is really the killer for any qualitative work, whether it's ethnographic or interview. What we want here are examples of things that have actually happened to Jane. So Jane says that my boss is a good leader. That's not as useful as Jane saying, my boss does this, and that's what helps me get my job done. So that's the kind of data that we're trying to get using this interview method. Yes, Jane?
Your phrasing there is, are there things that they do that help you or don't help you, which that do seems to be asking for stereotyping, as opposed to in the last week or in the last time period, give me specific examples of things that they did.
Yes. You're exactly right. So this is the simplification of that actual question. When you form these questions in the interview, you ask with respect to a specific task and within a specific time period, because time period will change a person's social network. Their social network on last month's tasks are going to be possibly completely different from 2 months before. So you ask, within this time period and this task, what did they do that you found helpful? What did they do? Exactly. Yeah, that's a very good point. Yeah.
You're not completely avoiding opinions and stereotypes, because obviously the things that they choose are based on their opinions and the stereotypes about what they can feel about the events.
So there's no way to get away from the fact that we perceive our situation with our own biases. And so you may perceive somebody as doing something bad to you that may not have actually happened, for example. But what we want to get are examples of things, so we try to get away from things that didn't really affect their task. And if they did mention this, then in a way that's important to them. And that's what we want to pick up. Things that have happened that they recognize as important to them, that's the data that we want.
So in other words, these questions are specifically chosen to be attitudinal, right? It's not that you're trying to get at, where does most of your coordination time go, right? Which you might get with a stopwatch and observation or something, right? But you're actually trying to get their attitudes about coordination.
Yeah. This method recognizes that we are beings in our own perceptual fields, and what we perceive as important to us is what we want to pick up in this case. Using the stopwatch method gets very good data in its own right, but what this tries to kind of fix from that method is we see somebody interacting, say, for 5 minutes with somebody in a hallway. Now, we're not exactly sure how that affected their task. We go and ask them, how did that interaction affect their task? Well, that really wasn't task-related, or it was a very small amount of impact. Whereas the communication that may have taken a very small amount of time very much impacted their task. Yeah. So there's benefits to every method, and hopefully by using multiple methods, that's where you really get the good data. You get triangulation. Yeah. So this is just one part. What I'm presenting today is just a small part of what I've done in the past. I've worked observing agile software development in Object Mentor in Chicago. I've also been involved with a very long-term project in Bell looking at their new product development. And I've also done this study in Microsoft Research over the past summer. We did a general study of coordination between software teams. We got around 400 behaviors from this. I'm going to be showing a very small portion of this study, which is equivalent to about 125 behaviors. I won't be telling you all of the behaviors, of course. I'll be telling you, so this is who we studied. This group grew from 20 to 300 people in 2.5 years, so extremely strong growth. We did 32 one-hour interviews, which are equivalent to about 450 pages of text, and we interviewed, for the purposes of this, what I'm presenting today, 13 people from a group called Application, and 7 people from a group called Platform. Application, as the names imply, we're building a customer-facing portion of the product on top of Platform's code. And that will become very important later. We interviewed, there's Jane, by the way. We interviewed PMs, devs, and tests in each group. And we also interviewed people from Boston and India, but I won't be discussing that. And I won't be discussing the tests because we didn't get enough interviews with tests. Boston and India have their own issues related to language and culture, which are very interesting, but I'm not dealing specifically with that today. So what is the overall finding from this study? Well, if we graph how the interactions are happening as a group, we have platform and application, and platform has their tasks, and application has their tasks. I'll just give a quote in order to really, that sums up the situation that we saw. We're consuming their stuff, we're not really giving them anything. So there's nothing that they really need from us or want from us. We want stuff from them, and we expect stuff from them. This quote kind of sums up really the point that I'm making in this talk, which is that there is an asymmetric dependency between these two teams. Application, yes?
The API between the platform and the application, was that negotiated? Was that set by the application team? Was that set by the platform team? The interface between these two systems.
I'm not exactly sure. From the interviews, I believe that there is a negotiation because they need to figure out what they're going to do in the next product cycle. And so platform has to agree to do something and to change the APIs in a certain way that benefits or that application needs to do their job.
And the application was the only customer of platform's APIs?
At the time that we studied, they were the primary customer, and a new team had just started up to become the second group that depends on platform, which would make this even more asymmetric, because now application is not even the only group that depends on them. Yeah. The consequence of this can be explained in another quote that sums up, I guess, the effect, is that I think that everyone is aware that there's a lot of tension between our teams. At least I definitely see it on the application side. And we've got quite a few quotes that indicate that there's tension and bad feelings between the two groups. So what I'm concerned with here is how does this asymmetry between the two groups affect what I've mentioned before, the behaviors, the perceptions, and the expectations. So the first finding, we want to know, are the perceptions actually different between the two teams? So when I say perceptions, I mean, if you focus on AppPM, how do they perceive the interaction between platform PM? Now that's indicated by an arrow going into application PM. So if we take applications PM's point of view, platform is sending behaviors to application. And if we take platform PM's point of view, application is sending behaviors to platform PM. We want to know what are the characteristics and what are the properties of those interactions. And really fundamentally, does each group perceive this as being different? Even though it's the same interaction, do they perceive the quality of that interaction differently? That's the question we're trying to get at. So if we graph, just very simply take counts of the number of helpful and unhelpful. So the percent of behaviors reported to be helpful versus unhelpful. For each link here, there's 3 links. application PM, PlatPM, PlatPM AppDev, and AppDev PlatDev. So for each of those links, what's the percentage of helpful and unhelpful from each point of view? So I'll just discuss the first here. Application PM perceives 73% of their behaviors are reported as being unhelpful versus 27% are helpful. And platform PM for the same link, 60% and 40%. So the important part here, I think, is the difference between the two, the slope, I guess, of the difference between helpful and unhelpful. So we can see that that is steep and that's a little less steep. That's extremely steep and that is actually in the opposite direction. So this link is interesting. These two are relatively similar slopes. So is there another way of looking at this maybe clarifies the issue? I think there is if you take what we know as an interaction effectiveness ratio. So just simply take the number of helpful behaviors over unhelpful behaviors, and we'll get a number.
Where number of
interviews,
people,
yeah, a number
or
of
number
people.
of behaviors.
No, number of people. Sorry, yeah, the number of behaviors. I think there's around 56, 60 behaviors in these two graphs. Yeah, we're stepping back a little. Yes, Carter.
So when you interviewed them, you asked them to report all the behaviors that had happened in a certain period of time that were helpful or unhelpful.
Yeah.
I guess I was assuming from your previous question that you'd said to identify an event, but no.
No, try to identify as many as possible until they're exhausted. They've exhausted their memory of things that are significant to them. Yeah. So this is just it's in effect it's a rough measurement. In qualitative work, by the way, this is not usual for qualitative work using numbers and graphs, but I'm trying to at least impart some kind of measure of objectivity, and I'm telling you exactly how much doesn't fit into my point of view, the argument that I'm making.
Did they have any idea that they were going to be asked this question, so it was something they would pay attention to, or?
No, no, this was the first time that they'd been asked. Yeah. Really, for qualitative work, the important part is in the quality of the statements, what's inside the quotes. But here I'm trying to give an overall view. So we can get that through interaction effectiveness.
So
yeah.
one more quick question.
Sure.
Is it typical for people in coordination studies to skew negative, or should I, as a Microsoft employee, be alarmed that people seem to be having such poor interaction with one another?
Okay, so the question is this normal to have poor interactions in coordination studies?
Well, when
yeah.
people talk about interactions, are they biased towards the negative, or is there some known effect about these things?
So, yeah. Well, we know from previous work on looking at the effectiveness of interactions, for example, in the Bell study, the average, a link effectiveness average was probably around 0.95. So in general, we get about the same number of helpful and unhelpful. So if you're very below that, then it's cause for alarm. But that is an organization-specific issue. So if you look at these numbers and you're alarmed, we can go through a process of improvement where you would say, okay, right now our average is 0.5. In next year, let's try to get that average up to 1. And then let's get it up to 1.5. Let's get, for every unhelpful behavior, let's have 2 helpful behaviors. That could be one way of improving the organization. But yeah, these are relatively low numbers compared to what I've seen before. Yeah. But in general, the perceptions are going to skew a little bit negative if there is a subordinate-dominant relationship between the two people. And I'll be talking about that in a second. Yeah.
So
yes?
Those numbers that you just mentioned, those 0.51, like higher is better?
Higher is better, yeah, because more helpful. Yeah, sorry. Yeah, helpful over unhelpful. So yeah, higher is definitely better. 1 is the same, obviously. So here we have application PM perceives this interaction as being relatively negative, and there's quite a few of those behaviors as being unhelpful. Platform PM, on the other hand, perceives it a little bit better, but still just generally not great. Application dev perceives the situation as being extremely negative, but platform PM perceives the exact same interaction as being quite a bit more positive. And platform dev and app dev are just generally in a pretty bad situation here. Thickness of the line indicates, it's a rough indication of the number of behaviors. So I would take, yeah, I would take platform dev and app dev interaction as with a low grain of salt, because there's not a whole lot of behaviors in that. And that's why I'm trying to be open and honest about it by putting the link as very small. Yeah, we can, the larger the link is better data. Now, the argument that I'm making here is I'm proposing the difference in perception is due in part to the task asymmetry. So because application's so dependent on platform, and that dependency is task related, platform's behaviors will severely affect application, but application's behaviors do not severely affect platform. And so that's, I believe, one of the reasons, at least in part, that we'll have a difference in perceptions. Previous research has indicated that with a dominant and subordinate relationship, the subordinate will perceive more negative behaviors from the dominant person, because if you're in a subordinate style of relationship, that dominant person's behaviors will really just generally affect you, and negative things become very more negative. And so just in general, we'll perceive, when you have an asymmetric relationship, you'll perceive more negative things. So at least this is somewhat supported by previous literature. Now, the next thing we're interested in are priorities. Are the priorities different? Or are the behaviors, the things that people actually do, are they different? And I found the main theme here is priorities. So of all the behaviors that application mentioned as important, so either helpful or unhelpful from platform, of all those behaviors, they mentioned a lot of the behaviors were related to priorities. Now, they do or they don't prioritize our needs. So application depends on platform to do things for them, and they perceive that platform doesn't prioritize those needs. Let's see to what extent. We'll see application PM, 5% of all the behaviors are related to priorities and they're helpful. 56% of all behaviors are unhelpful and they relate to priorities. Application dev, very similar. 44% of all their behaviors that they mentioned were related to priorities and they were unhelpful. Yes?
So did you see that the priorities was something you were going to speak about beforehand, or did it surface during your interviews?
Right. So for those out there, the question is, did we expect to find priorities in the data? No, not at all, because we went in there in a very exploratory manner and we're just interested in what's actually happening. This emerged from the data. Yeah. Which I believe is also a benefit of this type of method. We're trying not to impose our own view of the situation. We let the participants tell us what's important to them. And in this case, clearly application thinks that priorities are a problem. I'll give some quotes because that's what the really fun part is. I'm going to only give a few because I don't have time, but I've got so many we can discuss them later. Our critical dependency was not seen as a priority by them. 10 behaviors fell into that category. A quote, "The person in charge of specifying the feature, he was a contractor who has left for 6 months. So it seems like if I was going to develop a feature that a bunch of other people rely on, or if I was a manager and I was looking at all the people to assign to a feature, I would definitely not assign the feature that everyone relied on to the person who was going to leave." And I picked that because it's this particular behavior led to a lot of very bad impacts on this person's group. For example, because the person left, they had to give a work item to platform near the end of the iteration, and it severely affected work-life balance. It is difficult to get platform PM to do what we need them to do. Now that's also in general related to priorities, because obviously if platform prioritized applications' needs, they wouldn't have to bug them so much to get them to do what they needed them to do. You have to present a very strong case, and it's always difficult when you say, hey, you guys, you should do this. It'd make our job a lot easier. It's a difficult ask unless you can say, well, this is how it benefits you. And the third category is a hot potato feature. This I hadn't heard of before, but what happens is application needs platform to develop a feature X and then add Y to it, so X plus Y. But platform doesn't see that as an issue. They just want X. They think X is fine. So application, they have to take that feature and develop it on their own. But it's not part of their code base, and it causes a lot of issues. And then in the next iteration, management says, okay, that really belongs in platform. So in the end, it gets bounced around a number of times throughout features. And this is a feature that just nobody wants to deal with. Platform doesn't want to deal with it, and application can't deal with it. From Platform PM's point of view, the one comment that I found related to priorities is there's a little bit of tension in my thinking of two things. I'd like to interact more with them so that I know the direction they're taking so we can build the right things on the platform. On the other side, is that the best value for me, or should I just focus on the platform and the interaction we're having is good enough? So I don't know the answer to that. So here we can see that platform has trouble balancing priorities. So this difference in priorities, I'm arguing is a result of the task asymmetry. So just in general, this is a software engineering example of a fundamental law of human perception identified by the Gestalt psychologists. Attention is selective and focused. And then I argue because platform is not dependent on application in any significant task-related way. Platform's attention is focused on their own work. Hence, they prioritize their work highly and do not prioritize application's work. So for the next finding, we found that expectations are different also. I'll go through an example of this too, and that'll help really explain what I mean by application. So, by expectations. So expectation from application is, I want platform to do things for me. I find this is a very interesting category, by the way. To put our needs higher on their priorities, that's 18 behaviors. To be responsive to my emails about my dependencies, and to consume their code before they release it to us. So these are things application wants platform to do. On the other hand, platform tends to want application to refrain from doing things. So don't expect us to track your dependencies. Don't send too many or too complicated requirements, and don't escalate unnecessarily. So the expectations that each group has are different for each other. It's kind of an interesting finding. I did not expect to find this, actually. So what we found here is if we graph the number of expectations of things to do, an application is much higher. If we graph the expectation, don't do this, then platform. So platform primarily says, don't do this, don't do that. Effectively, be a good dependency and leave me alone. So from application's point of view, they expect platform to do things that makes their job easier because of this dependency, I'm arguing. In platform, because they're not task-related dependent on application. From platform's point of view, they expect application not to do things they consider to be unhelpful. So it's still, I think it's the reason for this is that the task-related interactions are asymmetric. Yes?
So in the first example, when you're talking about the perception asymmetry, you divided up the platform and application teams by role, by PM and dev, but you didn't do that for this one.
No.
Do you see a similar trend for if you divide it up by the three kinds of interactions?
Yeah. Well, because platform PM and platform dev, in this case, both expect their counterpart to still do things. So the role division doesn't really change this too much, and I wanted to simplify it for the presentation. Yeah. But yeah, if you wanted to really dig into the data, then splitting it up by role would give you a bit more a thinner slice of the data. a bit more information. Yeah, it's always better to split by role. In this case, I'm simplifying. So this study found 3 things. That task asymmetry affects our perceptions. The task asymmetry affects our priorities, how we prioritize our work. And task asymmetry affects our expectations. To give you an idea of why this is important, or why this finding is significant, I'll show you what we knew before. What we knew before from literature, and it's a lot of literature, says that as our interdependency increases, so do our number of helpful behaviors. Now, I think from what I've shown, we can now see that this is perhaps a highly inadequate way of looking at the situation. And I think it's because the way that organizational behaviorists thought of interdependency before, this concept they have of interdependency, is one of reciprocal interdependency, where it's good behaviors going back and forth. And I think anytime you take a look at a concept like this from the literature, and then you go into the real world and you do some actual real world observation and interviews, you find that concepts like this they're just not adequate to describe what's happening in the real world. Because this is not what interdependency is always like. It could be like this, it could be like that, it could be like this, like that. I think the only time you'll have this is in a very select few instances where you'd have perfectly reciprocal and helpful interactions. And that's what they mean by interdependency.
So,
yeah.
So as a manager or somebody who sees, I mean, what are the actions that I can take from these sort of findings? I mean, given that sort of in our business, the division between platform and app is almost inevitable, well, at least for certain classes of products.
Mm-hmm. Yeah, so the question is basically, I think, what do we do with it? What do we do about this when software engineering, in many cases, tries to split up groups into application and platform, right? So in this case, you have software engineering forces that say good software architecture demands clear separation and modularization and follow all the good stuff that Parnas told us, right? And social findings of this study show that perhaps that's not good for the social interactions between the teams. And I'm not sure how to balance that. I think that there's an interaction here that's really complex, and I can't give you a definitive answer until we look at the exact situation. So I'll give you the theory that I'm going to explain right now. It will give us a way of maybe analyzing a specific situation to see where that ideal amount of separation in interaction would occur. So we don't often see a black screen in a presentation, do we? So what? Why is this impressive? Why is this important? I think that's a really a reasonable question to ask. I ask it of myself all the time. We saw similar things happening in Bell in their new product development. We saw similar things happening in Object Mentor in their agile software development. It points to, I think, a crucial and essential issue in organizations. Why is this person unhelpful towards me? Why do these groups not coordinate well together? And how can we help them coordinate better? It's essentially Tom's question. So I'll dive a little deeper into this issue using a thought experiment and building up a theoretical model of coordination. And there's different ways to analyze this problem. We can analyze it economically. My background is, my undergrad is in economics, and we could construct game theory and do all that nice calculus with that. Or we could look at it dynamically, and I'll be choosing that tact using Levine's field theory. So let's start with a thought experiment. We have two participants, A and B. Now, A's task is to draw cards between 1 and 9. And they only have 2 cards at a time. And drawing a card costs $1. And their goal is to make 10 in the least number of cards, so maximize profit. So we can see that his goal set, the combination of cards that will satisfy his goal are going to be 5, 5, 4, 6, 3, 7, 2, 8, and 1, 9. So it's a very simple game, but it will lead to very complicated results. For the mathematically inclined, it's sampling with replacement, and all of that fun stuff. Now B's task is exactly the same as A's, except A gives his cards to B, and B's task is exactly the same, make 10 with 2 cards, except that B's cost is going to be a function of the difference between the 2 cards that A sends. So the cost per card is going to be $1 plus $1 times the difference in A's cards. So for 3-7, the difference would be $1 plus 1 times 4, so $5 per card. So you can see what we've done here is set up an asymmetry. We set up the situation such that A will output into B's task, and B will heavily depend on A, but A does not depend on B. The theoretical foundation I'm using is Levine's field theory, and I've added to it using other literature. And one way to look at this, the way I've chosen is using a work situation. It's highly simplified, and it's not exactly following field theory, but for this discussion, it suffices. A is in a work situation, and they've got 5 goal regions. Each of those regions of activity will satisfy his goal. So he can move into each of those regions. Now, each of the regions may have a valence, and a valence is positive or negative, and a valence corresponds to a force. So a positive valence is a force acting on A towards that region of activity, and a negative valence corresponds to a force pushing A away from that region of activity. So our question is, how will A behave given 3 and 7? Well, let's first assume that A doesn't know B's task and that there's no cost to cards, such that every goal region will have a positive valence with an equal force leading A towards any of those regions. Now it gets a little more interesting when we add cost and communication with B, because now if B communicates his situation, to what extent does B communicate it, and to what extent does A believe B, want to help B out, think that B's needs are important to him? So similar situation that we saw in the real world. Well, if A gets communications through whatever means, so IM, email, face-to-face, and believes it, then 5-5 becomes a positive region. And all the other regions become progressively more negative because B has told him, hey, 1-9, that's really going to mess me up. Don't give me that. But 5-5, all right, give me that. So that gives a positive valence and a corresponding field of forces drawing A towards it. What happens when A's cost increases? Or in other words, in real life, can A help B out, even if he wanted to? So there's a task constraint. If A's cost increases, say, to $1, then the forces acting on him to stay on 3-7 are going to increase because now it's going to cost him a lot of money to try to get to any of the other goals. So those goal regions become negative. It's costly. 3-7 becomes positive because he's already there, and it won't cost him anymore. What happens if his cost increases to $5? Well, the forces correspondingly increase because the same, each of these regions are equivalently negative, and 3-7 becomes much more positive. Now, what happens if A's goal is to maximize the difference between his cards? So we have this fuzzy concept in management called goal alignment. It's kind of mystical and mysterious, and this may be one way of getting down and saying what exactly happens when you say, my group's goal doesn't align with your group's. Well, in this case, the goals don't align because A is encouraged to get a 1-9. That becomes positive. All the other regions become progressively negative. And we can see that A is going to be encouraged by his task to do unhelpful things for B. So that's what we call task constraints, and that's how we can analyze it using field theory. So what happens if B escalates to management? There's another issue. We think, we know how this happens in the real world through the effect it has on people, but analytically, what's happening? Well, we get something called an induced force. So this force comes from outside A's work situation. It's the manager knocking on his door and saying, hey, come on, man, what are you doing? You're not really helping B out. He needs a 5-5. Can you just, be a sport? What happens when B's location changes? So in global software development, this is a very important issue. we think from software engineering literature that location matters. And there may be a difference between collocation versus down the hallway versus on another floor versus in another building, et cetera, and so on. But what's really happening to A's perception of his own work situation when we're collocated versus not? Well, this is one, as the theory would predict, what's going to happen is this. If we're collocated, there's an external or induced force on A to move towards helping B because B is sitting right next to him, can look over and say, come on, help a guy out. Now this is a lot more powerful induced force because they know each other, they work very close to each other, than, let's say, for example, being just down the hallway or in a water cooler conversation. It would predict that the force is going to be a little bit less. To what extent depends on the relationship, obviously, between the two people. But in general, we can expect a less induced force. Now, when it's over email or IM, the induced force may be even less towards the helpful behavior region. Interestingly, we found from the interviews that a picture may help. For some reason, one of the devs told me that having a picture on his email helps him coordinate with the people that are sending him email. This is a very curious thing for me because I would never have thought of this. So what happens when you have the picture? Perhaps the force gets a little bit stronger. What happens if the picture is happy? Does the face matter? Really? What if it's a happy face? What if the face is angry? Will that make a difference? What if the face is not congruent with the message of the email? Will that create some kind of conflict? These are questions I think are very important, and we could analyze and also observe and get through interviews. It obviously, I think, connects very closely to the problems in global software development and even telework. So what we've set up here is that one-way interdependency. What happens if we fix that and try to make it a symmetrical dependency? Well, I think what's going to happen is an induced force from B to the goal region is going to be now a lot more powerful because previously all B could do is escalate or just really try to get A to do what he wanted. There was no task-related way for B to get A to do what he wanted. Now, A's ability to do his task is going to be affected by B's output. So now, in political science terms, B is holding a much larger stick. Now that, I think, is going to be a much more powerful force than simply collocation. Because now when it's a task-related force, it's extremely powerful. Now the total result of all of these forces was what we call a resultant force. I'll show you, I'll build up a small combination here and we can see how it gets pretty complicated fast. So A knows B's situation, he's communicated. 3,7 was initially positive because that's what A has, but now it becomes a little bit negative. So there's two valences on 3,7 because B has told A that 3,7 is not good for me. Instead, try to do a 5,5. So the forces are now changing. What happens when the cost to A increases? So now there's an additional valence on 3,7, and the forces are going in different directions. This is a curious issue here. We call this conflict, because now A knows that he really should be going to 5,5 to help B out, but his task constraints are such that 3,7 is also equally attractive to him. So that conflict situation would happen a lot in real life as well. What happens if B escalates to management? The forces are changed by the induced force. What happens if B is on the same floor and meets in the water cooler? The forces are changed even more towards 5,5, and the resulting force is A moves to 5,5. So that's one way we can analytically look at a situation that's traditionally been kind of, using words and rather high in the sky. This analytic solution will lead to a phase space diagram, so we can analyze exactly how A perceives his resultant forces So we have A's work situations is on the x-axis, and we move back and forth. We're going to get a graph of the resultant force on A to be helpful or unhelpful. And at any point, so let's take this point, there's going to be what we call an equivalent of forces, a kind of a quasi-steady state equilibrium. So at this A's work situation, his resultant force will be to be helpful. And if we change that work situation, it's going to change his resultant force, going towards helpful or towards unhelpful. As you get into the middle, we can see there's an inflection point. I believe I'm predicting that that's because when we get to the middle there's going to be a sense of imbalance and tension due to the conflict of trying to choose between helpful and unhelpful. So A will very quickly move out of that region because there's tension and it's uncomfortable for A. So here is an analytical solution to the issue of will A coordinate with B? Yep.
Let's say task 1. Actually, let's say they don't coordinate on task 1 because A prefers to coordinate on task 2. So how does that, kind of like, I'm not going to help you with this one. We're going to do what's right for me. But on this task, we'll do what's right for you. Did you look at the intersection of 2 tasks?
So when there's 2 tasks, there would be 2 work situations for A. Well, it could be totally separate, but they might bleed into each other because if task A is, his behavior in task A somehow impacts task B, then there will be a force in the task B work situation as well, related to what happens in that. Yeah. So any work situation is with respect to a certain task. And if there other tasks do impact it, then that would be represented with respect to that task. Now, the contributions of this, I believe, it revises our current concept of interdependency. Obviously, our last concept was probably highly inadequate to describe what's happening in the real world. I'm proposing a field theory of coordination, which hasn't been done yet. I believe this leads to a better understanding of how the, or rather, sorry, a precise meaning for a lot of the abstract comments that are kind of flung around in management. It allows us to do a careful analysis and experimentation to dig deeper into how coordination really works. So why is this important for Microsoft? Well, the qualitative method generates just an extraordinary number of concrete, actual behaviors that have helped and not helped people get their jobs done. So for each of those behaviors, it's clearly something that we could increase or decrease. Each of those behaviors are extremely concrete and practical. And I believe that's one of the main benefits of the qualitative aspect. This could also be used as part of action research or continuous improvement program. So that's how we would, I think to address Tom's question, that's how we would very slowly and at the help of the management of the specific group that we're studying, we would be able to institute some kind of change to, perhaps if there is a heavy asymmetry and it's affecting the software teams, then we would go through and try to figure out how to adjust the other forces that are acting to maybe compensate for an application platform asymmetry. We've published this also, how to do that. Theoretically, it gives us a general theory of coordination, which is helpful because for Microsoft, it leads to basically, very fundamentally, a better understanding of how to structure teams and how to set groups and organizational goals and motivate employees and deal with conflict and burnout. Essentially, I think really the final thing here, essentially, is that we want coworkers to work together because of their work situation, not in spite of their work situation. So for future work, I have quite a few things I'm interested in. I'll only deal with a couple here. I'm interested very much in global software development. I believe a lot of large software companies are dealing with this issue. We're looking at it in Bell right now. They're having a problem with their outsourcing. And current results are rather inconclusive on what to do about global software development. And I believe that this approach, both the qualitative and ethnographic side, as well as the analytics side, might be able to shed some kind of light on the issues. Perhaps. And my second thing is that I'm interested in are extremely large-scale software development. This is what really got me interested in studying software in the first place, were the books by Fred Brooks and Weinberg, and then papers like Curtis's that really talk about how large software developments get done. And I've read so many books on software project management, probably in the dozens, but I realized that I actually don't know how software is really managed in the real world. And that came kind of as a shock to me, because if you read so much, you should know a little bit more about it, but I really don't know how it's actually done. So I think having a long-term ethnographic study of how software is actually managed might really be a benefit. I'm also interested in agile software development, and as Bagel Nagappan found, about a third of Microsoft now uses some form of agile. And it's very important to figure out how do agile processes interact with our current processes. Is that coordination going to cause problems, or is there any sort of issue that we should be aware of when a lot of our company moves towards a methodology? I'm also going to talk, the last part of this talk will be short, so we're almost done. I'm going to talk about an issue that I'm interested in, which is prediction through social simulation. My master's was on social simulation, and having recently read the work that Eric Horvitz is doing, I think that there's a real opportunity here to take a lot of the data that we have about software development, how it's being developed, and all of the systems that we have that hold these artifacts. And I know Gina's working on Bridge, so this kind of would build and feed into that and complement that work, I believe. We have, I'm sorry, I'm not a graphic designer, so we have components of software that are somehow linked together. We know that this is this is one level of analysis. If we overlay on top of that a social network analysis, then we have what's known as a social technical congruence, which is being worked on by Herb Sleb and a lot of other of his colleagues. Now, when we overlay the social network on top of the component network, we see where it matches and where it doesn't match. And the theory is that if it matches, it's better. I'm not exactly sure if that's true, but it's worth looking into, of course. What's interesting here is that the social network gives us the communication patterns, but it doesn't give us what my study showed, obviously, which is the interaction effectiveness, which I believe is a third level of analysis we can put on top. Now, what if we had a system that could automatically gather and generate this? To what extent it's possible, I'm not sure, but I'm really hoping that we could do something to generate this automatically. The system would be able to, without human intervention, figure out this congruency and then ebb and flow when it changes, so that now we know that A is a lot more central, a lot more, has a higher boundary spanning role than before. But we know that A's work situation is getting worse, that he's receiving a lot of unhelpful behaviors from his colleagues, and it's affecting his work in a way that the system can detect and say, hey, watch out, there's something bad happening here. And if A leaves our company, we'll be able to see exactly how it affects our systems. And we'll know that A is probably the last person we want to leave our company. We may also be able to help H find D, because right now he can't. We may help B find G. So in this case, we can use a system to automatically help connect people and to let them know when code is being updated that they should be aware of, and when social interactions are leading to very unhelpful situations. And hopefully we can predict when this would happen. It's something I'd really like to look into in the future. So to sum up, this talk has showed 4 things. One, that asymmetry has an impact on our perceptions. Two, that task asymmetry has an impact on our behaviors, in this case, how we prioritize our work. Three, asymmetry has an impact on our expectations. And four, I've shown that we can represent a person's work situation as a field of forces, both task forces and social forces that combine to move him in certain helpful or unhelpful directions. So maybe our behavior isn't entirely free will, that we're constrained and directed by the social and task forces that are acting on us. And maybe this will help us organize software development a little bit better in the future. Thank you very much. Yes, Corey.
Okay, so you demonstrated that there are differences in perceptions, behaviors, and expectations from the data that you gathered.
Right.
How do you know that it's this task asymmetry that's causing it, as opposed to other possible things
Yeah.
in their culture?
Yeah, I think that's a perfectly reasonable question to ask, and that's a fundamental problem of doing case study and qualitative research is we can't rule out other explanations. What we can do is get a lot of data to suggest that this is what's happening, and we would be able to demonstrate using a lot of data that this is happening, but we can't prove that there's no other explanation for it. What we can do is get other data that would support and triangulate. So I'm using interview methodology here, but we could also use ethnographic methodology, and we can use quantitative methods such as software engineering metrics that might be able to really buttress our argument here. But in terms of social science, the only way to definitively show something is through experimentation.
So, but what are you using to base these assumptions on, given that you only sort of have this one?
I'm using the qualitative data as an argument. Yeah, so I'm demonstrating that in this case, in this particular instance, this has occurred. And I can't say in other instances what would occur, of course, but we can theoretically propose that there is a link between asymmetry and perceptions. Yeah. Yes?
Can the word, those little gray arrows mean influences, but it really says negatively influences. Your data suggests that asymmetry negatively influences perceptions, behavior, and expectations. So is asymmetry the enemy or an enemy to effective collaboration? And if so, what can be done organizationally to either ameliorate the effects of asymmetry or to get rid of the asymmetries altogether?
Mm-hmm. So the question is asymmetry just in general the enemy, and should we try to get rid of it in all places? I think the previous literature in this demonstrates that asymmetry will lead to a lot of negative things. So definitely I think it's a negative influence. Because just logically, if application depends completely on platform, but platform has no dependency on application, then naturally there's no way for application there's no stick. Application doesn't have a stick. And so, yeah, it's predominantly negative. In order to fix it, I think you'd have to go through definitely a case-by-case basis. And in some cases, you might not be able to get rid of the asymmetry. But there may be social and other task-related things that we can change, and maybe analytically we could demonstrate how that would change. Then you change those other forces that would lead us to helpful behaviors. It doesn't necessarily have to be this change that will lead to a positive change. Yeah. Yes?
Yeah, did you have a chance to get the different groups together and present these results to them? And if so, I mean, what did they have to say about it? And if not, do you think that'd be a good idea, and what do you think they might say?
Actually, Andy, I think, has done a lot. Since I left, Andy has been with them a lot more, right? and you presented and discussed ways of making a difference. So I think he's better to answer that question.
We've been with the group several times. Chris actually did get to present his results to the group itself. There were two responses. One was, of course, this just confirms our intuition about how our groups are behaving towards each other. The other one was, we definitely have to do something about it. And the last I left it with them was they wanted someone from MSR, so I was basically trying to drive change into their group. But they have to want to help themselves, and at this point, they seem to. Let's just say, out of 8 engineering managers that I spoke to, there are 8, and then there's 2 general managers above them. 7 of the 8 of them were of the opinion that they had already made changes that they thought might help the interactions to make them more helpful, though from what I could tell, they didn't actually change anything at all. And then one of the 8 actually still wants help to improve things, and he's more of a tool-centric person, so he's interested in awareness tools that might help make developers a little more aware of what's going on when they're not getting communicated with by their dependencies.
Yes.
So it seems like Microsoft, this is like a very common problem with this sort of techno-centric approach we seem to take, and then there's a lot of people saying, well, what about the customer? And it seems like if you had a notion of a persona or a customer or some third thing here, the app person could say, I need this change, and if I don't, this customer becomes much more unhappy. So there's like a third force. It seems you do need to triangulate somehow. And we've done things like in Visual Studio, they have personas, and I wonder, of course, it's not a management thing. It's more of a culture thing, really. It's not saying there is this customer, who's talking to the platform and app, but actually maybe if there were, you could actually, almost like a mediator or somebody who's saying, I'm going to be really unhappy with, without this feature. But it just seems like this setup is just designed for friction. I don't know. You can do things to minimize it, but unless like the platform people sort of have a better view of the customer and how the app requests are related to customer happiness, satisfaction, and dissatisfaction. It's a hard situation.
Yeah.
If that's the.
Yeah, you can. This is such a simplification for the purpose of this talk that a task structure is not as this simple, obviously.
Right, and also the platform doesn't
and we
succeed
could,
unless there's killer apps that use the platform, right? So
that's right. So at a very high level, yeah.
Right, but even the platform by itself is not a product. So without the app, the platform has nothing.
Yeah.
So it seems also like the platform really should be caring about these guys, right? The platform is dependent on the app for success.
Yeah.
Well,
you'd think so, yeah.
Well, to follow up on what you're saying, though, don't you really want an asymmetry in the sense that just by the use of the term platform, you can have multiple apps on the platform.
Right.
And the platform can't spend all its time listening to one app.
Sure.
Now, the app only has one platform, and it does have to spend its time listening to it. And clearly, the platform needs to pay attention to the whole set of apps. But you can't have it. You really want an asymmetry in that it just can't spend all of its time looking at each app to the same degree. So
that's right, and maybe that's another thing that's sort of missing here is just the realization that this platform group is dealing with multiple app groups.
Yeah, your point about
balance.
the killer app is the one that's going to get attention is kind of signals that fact that they have to decide who they're going to. Now, if they're not listening to any of the apps, then you've clearly got a problem. But how?
Didn't you say that in the beginning, though, that in your case study that this app was the only app for that platform?
At the time that I studied, there was a second application that had just started up. Yeah.
So does that mean that you'd see the same thing if you just change Plat app 1 to component 1 and component 2, as an example?
Yeah, depending on the amount of influence that each has. In this case, platform has all the influence. Yeah. So one thing that I think we've been talking about here is that this is an issue in software development just in general, that you want this platform to not really depend on application because that's a fundamental principle of architecture. So one way of fixing this would maybe be to have group forces acting on platform, such that right now platform doesn't really care about application and they're not influenced to care. There's no forces acting on platform to take applications requests seriously. So you would change those forces. You would make it so that platform really depends, not perhaps task-related dependence, but performance-related dependence, management-related dependence, or communication-related dependence that would take place, that would fill in this gap here. So that, for example, platforms' performance review extremely depends on the opinion of application. And applications asked, did platform do what you needed to do? And they said no, and in that case, platform is like, look, your job is to help application, and you're not helping them. That could be one way of fixing it. Yeah.
Let me ask a high-level question. Does asymmetry in perception, behavior, and expectations lead to bad software, or lead to buggy software, or software that would get Microsoft in trouble? Like, is this the ultimate thing here for Microsoft is we sell software to people. Right. Are they not going to buy our software, or are we not going to be able to actually produce the software if we keep these behaviors? Or is this something we actually need to fix?
Well, from what the data interview, I haven't presented that data here, but from some of the other interview comments, the effect that this asymmetry has is that application can't get its features in when it needs it to get its features in. So that obviously would affect. Work items are placed very late on platform's plate because they didn't deal with it when they should have. That affects software. So there's definitely a software effect. But there's also a human effect that if these people aren't happy, they're going to leave, and they're going to have a bad work-life balance, and they're going to be generally just very unhappy and unproductive. So that also would overall affect software. Yeah. Yeah. So there's two. Sorry. Go ahead.
It seems like there's these forces already in place that over time do act on the platform. But what's missing is the perception of the platform on what those forces are and how they're eroding or starting to build up.
Yes, exactly. Yeah, that's the exact point here, is that at this moment, platform does not perceive the forces to be in this direction. Exactly, yeah. And it should all be with respect to platform's point of view. It doesn't matter what management says. One of the platforms that I interviewed, one of the platform devs, said at a high level we do have on our commitments to help out application. But obviously that has not filtered down to task-related forces.
So do you think there's an opportunity with tools to increase that perception of how those forces are acting on the platform to improve the asymmetrical?
Yeah, I think one of the goals of HIP is to make tools that help us communicate and to realize our effect on others, right? So that could be one of the ways. Yep. Sorry.
I think that one other thing you have to keep in mind is the platform is also getting requirements from security and privacy, from operations and sustained engineering. So it's not likely that they're ignoring the app guys, that they don't want to help those guys. It's just that they have a list of different,
yeah, they're dealing with their own constraints. That's part of the capacity issue. They have their own task constraints which draw them towards this region. Yeah, absolutely. So it's a very complicated issue. It's not just simply that platform doesn't want to help. It's maybe platform is completely constrained towards this direction. Yeah. Yes?
So let's say there was a group at Microsoft that had 10 dependencies. Like, could you still analyze it, or with this kind of methodology, or does the graph just get way too complex?
Well, it would take time. But I really want to do it. That's really the fun part.
All right, well, let's thank Chris one more time.
Thank you.